Welcome aboard the Cosmic Drift Chronicles. You are about to leave behind the familiar, leaving Earth and the noise of the world far below. Here, in this vessel, suspended in the infinite black of space, there is only the gentle radiance of distant stars, the soft hum of cosmic energy, and the vast, unbroken stretch of the universe ahead. Take a moment to settle in. Feel the weight of your body releasing. Your breathing slows, deepens, becomes steady and calm. There is no rush here. Time moves differently in space. A moment can stretch into hours. Hours can pass like seconds. As you adjust your gaze to the void, notice how the Earth, your home, rotates slowly beneath the atmosphere. Clouds drift in delicate swirls, their patterns shifting almost imperceptibly, painting white brushstrokes across blue canvas. Oceans reflect the sun in bright, shimmering light, their surfaces rippling with gentle waves that travel thousands of miles before dissolving into calm. Continents stretch quietly beneath, shaped by billions of years of geological time. Mountains rising and eroding, rivers carving valleys, deserts shifting grain by grain. The familiar colors of blue, green, and brown contrast against the thin white veil of clouds, forming patterns that are intricate and alive. Watch them move. Notice how storm systems spiral slowly, how coastlines trace the boundaries between land and sea, how city lights begin to appear on the darkened side of the planet, tiny pinpricks marking human presence in the vastness. The moon hovers nearby, a pale, cratered orb. Its surface is ancient, covered with scars from countless impacts spanning 4 billion years. Craters overlap craters. Maria, dark plains of ancient lava, spread across its face. And yet it gleams faintly in the sunlight, a steadfast companion to the planet it orbits, locked in eternal dance, always showing the same face to Earth below. Beyond it, Mercury, Venus, and Mars move in silent procession, small spheres of rock and metal, each with its own history, each following the invisible threads of gravity. Mercury, closest to the Sun, scorched and cratered. Venus, shrouded in thick clouds of sulfuric acid, hiding a surface hot enough to melt lead. Mars, the red planet, dusty and cold, holding ancient riverbeds and polar ice beneath its rusty surface. Slowly we ascend. The curvature of the Earth becomes more pronounced, the blues of the oceans deepening into darker shades, the continents shrinking into patterns, until they are no longer individual landscapes, but part of a whole, a single planetary jewel suspended in black space. The thin atmosphere glows faintly at the edge, a fragile bubble holding life in perfect balance, just 100 kilometers thick, nothing compared to the vastness beyond. Our sun, once dominant in the sky, begins to recede, a distant point of warmth, radiating light across billions of kilometers. Its corona glows softly, visible now as delicate wisps extending into space, scattering faint rays across the solar system. The solar wind streams outward invisibly, carrying charged particles to the furthest reaches of the sun's influence. The planets, previously familiar, now drift in a slow, majestic parade. Jupiter, immense and commanding, rotates with a visible banding of clouds, layers of ammonia and methane creating stripes of cream, rust, and brown. Its great red spot, a storm persisting for centuries, swirls slowly, larger than Earth itself. Around Jupiter, dozens of moons orbit in precise patterns, each a world unto itself. Saturn's rings extend in delicate arcs, casting shadows across the giant planet, fragments of ice and rock sparkling faintly in sunlight. From this distance, the rings appear solid, but they are composed of countless individual pieces, each following its own orbit, creating gaps and waves as they interact with Saturn's moons. Uranus and Neptune, distant and serene, glimmer in shades of pale blue and deeper azure, their cloud tops faintly marked by winds and storms moving at hundreds of miles per hour. Their atmospheres are thick with methane, which absorbs red light and reflects blue, giving them their distinctive colors. They rotate slowly, tilted at unusual angles, their seasons lasting decades. Beyond them, the Kuiper belt stretches, a faint, icy ring of distant bodies orbiting the sun. Pluto drifts here among thousands of similar objects, small and cold, yet each carrying fragments of the solar system's history, pristine samples from the era of planetary formation billions of years ago. As we leave the planetary orbits, the solar system recedes. The sun itself becomes a pinprick of light, distant yet vital, illuminating the path ahead. The glow of the Milky Way begins to appear on the horizon, a band of soft white light composed of billions of stars, stretching across the black void. Spiral arms, dense with stars and cosmic dust, promise the journey that awaits, an expanse of time and space that exceeds imagination. Every moment is an opportunity to observe, to notice the faintest details. The subtle reflection of light off an asteroid belt, the distant glow of a comet's tail streaming millions of miles behind its icy nucleus, the soft shimmer of solar wind across empty space. The silence is profound, broken only by the imagined motion of the ship drifting across the solar system. Each movement is slow, deliberate, and gentle, emphasizing the vast scale and the beauty of cosmic mechanics. Notice your breathing now. How it has slowed. How your body has settled. You are safe here, suspended in this moment, drifting peacefully through space. And so we begin. Leaving the familiar orbits, we drift outward, guided by the light of the sun, through the outer reaches of the solar system, and toward the distant spiral arms of our galaxy. There is no destination. Only the journey. Only the gentle drift through infinite space. Beyond Neptune, the solar system thins. The sun, once a radiant sphere dominating the sky, now hangs as a faint, distant light. No brighter than Venus appears from Earth. The planets are distant orbs, subtle against the blackness of the void, their details lost to distance. The Kuiper belt recedes, a ghostly halo of ice and rock, each fragment glinting faintly in sunlight that has traveled for hours to reach this far. Interplanetary space is a quiet expanse. Microscopic dust drifts slowly, almost imperceptibly, across billions of kilometers. Each grain follows its own elliptical path, set in motion long ago by collisions or gravitational nudges. They move in silence, patient, timeless, part of the solar system's slow recycling of matter. Occasionally, a comet appears, a bright streak of light with a long tail that traces its journey outward, particles scattering along a path set long ago. These ancient wanderers, composed of ice and dust from the solar system's formation, journey from the distant reaches toward the sun and back again, their orbits taking centuries or millennia to complete. As they approach the sun, they warm, releasing gas and dust that streams behind them in twin tails. One of dust, curved by orbital mechanics, one of ionized gas, pushed straight back by solar wind. Here, in the inner void beyond the planets, distances stretch unimaginably. Light takes hours to traverse the space that seconds ago would have been crossed in moments. At this distance, a message sent to Earth would take half a day to arrive. Communication becomes theoretical. Presence becomes abstract. Silence dominates. There is no atmosphere to carry sound, no wind to shape the void, only the motion of bodies in space, governed by gravity and momentum. Everything moves, yet nothing seems to change. The dance of celestial mechanics unfolds at a pace beyond human perception. Far ahead, the Oort cloud glimmers faintly, theoretically invisibly. Trillions of icy bodies orbit at unimaginable distances, spread across a spherical shell that extends halfway to the nearest stars. These objects are so distant, so faint, that none have ever been directly observed. Yet their presence is known through the comets they occasionally send sunward, nudged by passing stars or gentle tidal forces from the galaxy itself. Their slow, silent motion marks the threshold between our solar system and the interstellar medium beyond. Here, the sun's gravity weakens to almost nothing. Objects at this distance take millions of years to complete a single orbit. Some drift so far that they barely remain bound to the sun at all, hovering at the edge of escape, waiting for the gentlest push to send them into the galaxy beyond. As we pass this boundary, the sun fades further, its warmth a memory, its light a distant guide. The temperature here hovers, just above absolute zero. Any heat that remains is ancient, carried from the inner solar system, or absorbed from the faint starlight that pervades all of space. Now, the interstellar medium surrounds us. Tenuous clouds of hydrogen and helium, sparse dust grains, magnetic fields stretching across light years. The density here is almost unimaginable, just a few atoms per cubic centimeter, far thinner than the best vacuum achievable on Earth. Yet across vast distances, this near-nothingness accumulates into clouds, structures, patterns that shape the space between stars. Occasionally, a distant star twinkles in the emptiness, alone, like a distant beacon in a black ocean. These stars are our neighbors in cosmic terms, just a few light-years away, yet they remain impossibly distant, separated by gulfs that light takes years to cross. Our trajectory carries us through the void between stars, past remnants of ancient supernovae, clouds of gas and dust that may someday birth new stars. These remnants drift outward still, expanding from explosions that occurred thousands or millions of years ago. Their motion slowed but never stopped, carrying the enriched matter of dead stars into regions where future generations will form. Here, the scale of space is apparent. Every distance, every motion, stretches beyond comprehension. A single light year, the distance light travels in one Earth year, is nearly 10 trillion kilometers. The nearest star is more than 4 light years away. The galaxy spans 100,000 light years. And this is just the beginning. Yet, there is beauty in this emptiness, a vast, quiet canvas upon which the universe writes its history in light and matter. The darkness is not hostile. It is patient, neutral, infinite. It holds space for everything that exists and everything that will exist. Small stellar neighbors appear. The faint red glow of Proxima Centauri, the pale light of Alpha Centauri A and B. These stars, close in cosmic terms, shine dimly from the distance, each surrounded by invisible planets, worlds unseen but inferred through careful measurement, silently orbiting in the dark. Proxima Centauri is a red dwarf, small and cool, burning its fuel so slowly it may shine for trillions of years. Alpha Centauri A and B form a binary pair, two stars locked in mutual orbit, circling each other over 80 years. They are similar to our Sun, yellow, stable, ancient. Around them, worlds may exist where liquid water pools on rocky surfaces, where atmospheres hold in warmth, where chemistry unfolds in ways familiar or strange. The scale is immense, yet familiar, a first taste of the vastness that awaits in the Milky Way. These stars represent our closest stellar community, the neighborhood of the Sun, bound loosely together by motion through the galaxy. As we drift through these first stars, we notice the soft patterns in the interstellar clouds, the wisps of gas reflecting distant starlight. Some clouds appear as faint patches against the background, glowing dimly where radiation from nearby stars excites their hydrogen into emission. Others are dark, silhouetted against brighter regions, cold and dense, waiting for gravity to gather them into something new. Sometimes, a faint cosmic ray passes, invisible yet traveling at near light speed, a messenger from a distant corner of the galaxy. These high-energy particles, protons, atomic nuclei, occasionally electrons, have been accelerated by supernova shockwaves or magnetic fields around neutron stars. They travel for thousands of years, crossing vast distances, carrying energy across the void, seeding distant clouds with radiation that may someday trigger new rounds of star formation. These are the building blocks of creation, carrying matter and energy across the void, distributing the elements forged in stars to regions where they will form planets, asteroids, and perhaps life itself. Nothing in the universe is wasted. Every particle, every photon, every quantum of energy participates in the cosmic cycle. We move carefully, observing each detail, the subtle gradients of light across gas clouds, the pale glow of distant stars, the occasional flicker of a far-off supernova's afterglow. The journey is slow, deliberate, allowing time to appreciate the scale, the silence, and the elegance of the cosmos. Your breath continues, steady and calm. In and out, rising and falling. Like the slow expansion of these ancient gas clouds, like the patient drift of matter through space. There is no hurry. The universe has all the time that exists. And so do you. We drift onward, deeper into the space between stars, toward the gathered light of the Milky Way. The faint glow of our Sun is now lost behind us, reduced to just another star among countless others. If we turned back, we could not distinguish it from its neighbors, could not pick it out from the thousands of similar yellow stars scattered across this region of space. Ahead, the Milky Way opens itself fully, a vast spiral of light and shadow stretching across the darkness. From within, it does not appear as a distant structure, but as an encompassing environment, a realm of light and matter that extends in every direction. We drift into one of its spiral arms, where stars are more numerous, closer together, and brighter. Here, space is no longer an empty black void, but a layered tapestry of light, dust, and motion. White and yellow stars glow steadily, their light constant and reliable, shining as they have for billions of years. Cooler red dwarfs flicker faintly in the distance, small and dim, the most common stars in the galaxy, though barely visible from afar. Blue giants burn with quiet intensity, their light sharp and brilliant, illuminating the clouds around them with pale blue radiance. Between these stars, enormous nebulae drift silently. These clouds of gas and dust stretch across dozens, sometimes hundreds, of light years. They glow softly where nearby stars excite their gases, painting the darkness with subtle reds from hydrogen, deep blues from oxygen, and muted violets from sulfur. Some nebulae appear dense and opaque, blocking the starlight behind them, creating dark rifts across the glowing band of the Milky Way. These are stellar nurseries, cold and thick with dust, where gravity slowly draws matter together, forming the seeds of future stars. Within their depths, processes unfold that will eventually produce new solar systems, new planets, new opportunities for complexity and change. Others are thin and wispy, barely visible except as faint shadows against the galactic glow. These remnants of old stars or regions swept clear by stellar winds form delicate structures, filaments and shells that trace the invisible forces shaping this space. As we move deeper into the Milky Way, star clusters emerge. Hundreds or thousands of stars gather together, bound by gravity, moving slowly as a group through the galaxy. Some clusters are young, their stars bright and hot, still surrounded by the remnants of the clouds that formed them. The Pleiades, visible from Earth, would appear from here as a brilliant jewel box, its blue stars still wrapped in faint wisps of dust that scatter their light. Others are ancient, their stars dimmer and redder, survivors from the early history of the galaxy itself. Globular clusters, dense spheres of hundreds of thousands of stars, orbit the galactic center in long, elliptical paths. Their stars are among the oldest in the universe, formed when the galaxy was young, before heavy elements had been widely distributed by earlier generations of stars. The galaxy is not static. Everything here is in motion. Stars orbit the galactic center, following vast, curved paths that take hundreds of millions of years to complete. Our Sun completes one orbit every 230 million years. It has circled the galaxy roughly 20 times since its formation. Clouds of gas slowly collapse under their own gravity, fragmenting into dense cores that heat and compress until nuclear fusion ignites, and new stars are born. This process continues throughout the galaxy, creating approximately 7 new stars each year, maintaining the population even as old stars fade and die. Old stars shed their outer layers, enriching the surrounding space with heavier elements. Planetary nebulae, glowing shells of gas surrounding dying stars, expand slowly outward, eventually dispersing into the interstellar medium. Dust drifts, settles, and is stirred again by stellar winds and the gentle pressure of starlight itself. We pass through regions where supernova remnants linger. These are expanding shells of gas, the aftermath of massive stars that ended their lives in immense explosions. Their debris spreads outward, glowing faintly as it cools, sometimes for thousands of years. The Crab Nebula, the Veil Nebula. These structures mark the graves of stars, yet they are also fonts of creation, carrying the elements that will one day become part of planets, moons, and perhaps living worlds. The shock waves from these explosions ripple through nearby clouds, compressing them, sometimes triggering new rounds of star formation. Death and birth intertwined, the cosmic cycle perpetuating itself across billions of years. Light here behaves in complex ways. It filters through clouds, scattering across dust, and reflects off distant stars in subtle patterns. Some regions appear dense with light, thousands of stars visible in a single field of view, their combined glow creating a soft, diffuse radiance. Others are carved into deep, dark lanes where dust blocks our view entirely, creating the appearance of empty voids where in reality, matter is simply hidden. These dark lanes cut across the Milky Way like rivers of shadow, marking regions where future stars are slowly forming, where the temperature is just a few degrees above absolute zero, where molecules form on the surfaces of dust grains, water, carbon monoxide, methanol, and complex organic compounds. Time feels stretched in this environment. A single second of thought corresponds to thousands of years of stellar evolution. Stars that appear unchanged to us are, in reality, constantly transforming, burning fuel, shifting color, growing or shrinking, moving slowly through the galactic disk. What we see is a snapshot, a frozen moment in processes that unfold over timescales we can barely comprehend. As we continue drifting, the scale becomes overwhelming. The Milky Way contains between 200 and 400 billion stars, and we are passing through just one small region of it, one spiral arm among several. Each point of light could host planets. Each planet could hold landscapes, atmospheres, oceans, storms, seasons, or something entirely unfamiliar. Yet despite this density, there is an immense sense of calm. Distances are so vast that collisions are rare. Stars pass within a light year of each other, only once every few million years. Motions are slow and graceful. Nothing rushes. Everything follows its path, guided by gravity and time, each star carrying its momentum through the galaxy, each cloud drifting slowly in the gentle currents of the interstellar medium. Ahead, the galactic core glows brighter. Stars become more concentrated, their light blending together into a dense, luminous haze that stretches across thousands of light years. The center of the Milky Way is obscured by thick dust clouds when viewed in visible light, but its presence is unmistakable. Gravity here is stronger. Orbits tighten. Stars move faster, bound more closely to the supermassive black hole that anchors the galaxy's center. This black hole, Sagittarius A*, contains roughly 4 million times the mass of our Sun, compressed into a region smaller than the orbit of Mercury. It pulls everything nearby into faster orbits, creating a dense cluster of stars in the galactic nucleus, some of which complete their orbits in just a few years rather than millions. We do not approach the core directly. Instead, we drift along the spiral arm, observing the galaxy from within, surrounded by its light, immersed in its structure. The Milky Way is not just something we see. It is something we are inside of, something that surrounds us completely, above, below, in every direction. Slowly, almost imperceptibly, the density of stars begins to thin again. The glow of the galactic disk fades. The spiral arm stretches behind us. We are moving outward, away from the crowded regions of the galaxy, toward the quieter outskirts where stars are fewer and the darkness grows deeper. The galactic halo begins to reveal itself. A sparse, spherical region surrounding the disk, containing ancient stars and globular clusters that orbit far from the bright center. These stars are metal-poor, formed when the universe was young and had not yet been enriched by successive generations of supernovae. The Milky Way begins to reveal its full shape. What once surrounded us now becomes something we can observe from a distance. The luminous band of stars narrows, then curves, then slowly pulls away as we drift beyond its outer regions. Your body has settled deeper now. Your muscles have released their tension. Your mind has grown quiet, following the gentle drift through galactic space. There is nothing to hold on to, nothing to control. Only the slow, peaceful journey outward. The galaxy recedes behind us. Ahead lies the vast darkness between galaxies. The Milky Way no longer surrounds us. What was once an all-encompassing ocean of stars now begins to pull away, its spiral arms thinning into a luminous haze against the darkness. Individual stars fade, their light merging, blending into a soft, continuous glow that spreads across the disk. The dust lanes and nebulae that once drifted close now merge into a distant texture, barely distinguishable from the background of space, details lost to distance. We are leaving the galaxy. As distance increases, the Milky Way reveals its full form. A vast spiral disk suspended in the void, its arms curved gracefully around a brighter central core, like a cosmic whirlpool frozen in time. From this perspective, its immense size becomes apparent. 100,000 light-years across, containing hundreds of billions of stars, yet now reduced to a quiet, glowing structure drifting behind us, growing smaller with each passing moment. Around the visible disk, a faint halo of stars becomes visible, a spherical distribution of ancient star clusters and isolated stars that orbit far from the galactic plane. These objects trace long, elliptical paths, some taking billions of years to complete a single orbit, remnants from the galaxy's early formation. Ahead lies intergalactic space. This region is unlike anything encountered before. Stars are no longer nearby. The density of matter drops dramatically. Light sources become rare. Darkness deepens, not as an absence, but as a presence, a vast, enveloping stillness stretching for millions of light years, a silence more profound than any encountered within the galaxy. Intergalactic space is not empty, though it appears so. It contains faint traces of gas, the intergalactic medium, composed primarily of hydrogen and helium left over from the universe's early moments. These atoms drift in isolation, sometimes encountering another particle once every few years, moving slowly through volumes of space larger than entire galaxies. Hydrogen atoms float alone for eons before encountering another particle. They carry no memory, no purpose, simply existing in the void, waiting. Some may someday be drawn into a galaxy, incorporated into a star, fused into heavier elements. Others may drift through intergalactic space for the entire lifespan of the universe, never interacting with anything. Radiation from the earliest moments of the universe permeates everything, faint and uniform, a quiet echo of the cosmos's beginning. This cosmic microwave background fills all of space, stretched and cooled by billions of years of expansion, now reduced to a temperature just above absolute zero, but still present, still detectable, still carrying information about the universe's first moments. Distances here are measured not in thousands of light years, but in millions. Motion becomes almost abstract. Galaxies drift slowly relative to one another, their movement so gradual it feels timeless, measured over billions of years. The expansion of space itself carries them apart, not through motion within space, but through the stretching of space itself. Far ahead, a soft glow begins to emerge from the darkness. This is the Andromeda Galaxy, a massive spiral, similar in structure to the Milky Way, yet distinct in form and light. As we approach, its shape sharpens. Dust lanes curve inward, tracing spiral arms. Star-rich regions glow softly, concentrated toward the center. The outer halo of faint stars extends far beyond the visible disk, a diffuse cloud surrounding the galaxy like a ghostly aura. Andromeda is approaching the Milky Way, drawn by mutual gravity. In several billion years, the two galaxies will collide, merging into a single, larger elliptical galaxy. But that is far in the future. For now, they drift separately, two island universes in the vast sea of space. We do not stop. We drift past Andromeda at a great distance, observing it as a whole rather than entering its spiral arms. From here, it appears as a complete system: stars, dust, gas, dark matter, all bound together by gravity, all moving as one through the cosmic web, all participating in the slow evolution of structure across cosmic time. Beyond Andromeda lie countless other galaxies, members of the local group, a collection of more than 50 galaxies bound loosely together by gravity. Some are spirals, thin and elegant, their arms traced by young blue stars. Others are elliptical, smooth and rounded, their stars distributed in dense, featureless glows, having long ago exhausted their gas and ceased forming new stars. Some are irregular, chaotic in shape, distorted by gravitational encounters long ago, their structures disrupted by tidal forces. Between these galaxies stretch immense voids, regions where almost nothing exists. These voids span tens of millions of light years, forming the largest structures in the universe. They are not completely empty, but their density is far below average, containing perhaps 1/10 the normal amount of matter. Along their edges, galaxies cluster together, tracing vast filaments of matter that resemble a cosmic web, sheets and strands of galaxies surrounding empty regions, creating a foam-like structure on the largest scales. We drift along one of these filaments. Galaxies appear sporadically, each separated by enormous distances. Their light is ancient, traveling for millions or billions of years before reaching this point. What we see is not the universe as it is now, but as it was deep in the past. Light carries time within it, preserving images of distant eras. Each galaxy we observe is younger than it is now. The light we see departed from those galaxies long ago, when the universe was different, when stars were younger, when some galaxies had not yet formed. We are looking backward through time, observing cosmic history written in light. Occasionally, a brilliant point of light appears, a quasar. At the heart of a distant galaxy, a supermassive black hole consumes surrounding matter at an astonishing rate, releasing immense energy as material accelerates to near-light speeds before crossing the event horizon. These objects shine brighter than entire galaxies, visible across vast cosmic distances, beacons from the early universe when such active galaxies were far more common. Their light pierces the darkness, momentarily dominating the scene before fading back into the background. Some quasars are so distant that their light has traveled for billions of years, showing us galaxies as they appeared when the universe was young, when star formation was more vigorous, when galaxy collisions were more frequent. The further we drift, the quieter the universe becomes. Galaxies grow smaller and dimmer. Space stretches wider between them. The sense of isolation increases, not in a threatening way, but in a profound, humbling one. We are far from any shore, suspended in an ocean too vast to comprehend, observing islands of light scattered across infinite distance. Here, scale loses meaning. The human sense of distance dissolves. Millions of light years feel no different from billions. Our minds cannot grasp such scales directly. We can only observe, acknowledge, and surrender to the vastness. Motion is slow beyond perception. Individual galaxies appear frozen, unchanging, though in reality they rotate, evolve, interact over timescales of hundreds of millions of years. The universe unfolds not in moments, but in epochs, each lasting longer than all of human history. The Milky Way is now barely visible, just another faint galaxy among many, no longer special, no longer home, simply one point of light among billions. There is no privileged center, no special position. Every galaxy is simply one of countless islands of light drifting through an immeasurable sea. As we continue outward, the distribution of galaxies becomes more uniform. Clusters and filaments smooth into a near-even spread of faint points. This is the large-scale structure of the universe revealing itself. Not chaotic, not random, but subtly ordered across unimaginable distances, shaped by gravity over billions of years, reflecting the tiny fluctuations present in the universe's earliest moments. Light grows redder. The expansion of the universe stretches wavelengths as they travel, shifting colors toward the red end of the spectrum. Distant galaxies glow faintly, their light weakened by both distance and time, their colors altered by the stretching of space itself. Blue stars appear green, then yellow, then orange, then red as their light travels across expanding space. The most distant galaxies are visible only in infrared wavelengths, their light stretched beyond what human eyes could see. We are approaching a boundary, not a physical wall, but a limit of perception. A horizon beyond which light has not yet had time to reach us. The observable universe begins to define itself here, shaped not by edges in space, but by the finite speed of light and the age of the cosmos. The darkness deepens further. Galaxies thin to scattered points. The cosmic web fades. What remains is a vast, uniform field of distant light, nearly identical in every direction, a sky filled with the faintest imaginable glows. This is intergalactic space at its most extreme, quiet, ancient, and immense. A realm where the universe feels less like a collection of objects, and more like a continuous, boundless expanse, where matter is rare and darkness is patient. Your breathing has become almost imperceptible now. Your body weightless. Your thoughts drifting, scattered, dissolving into the vastness like light into darkness. There is nothing to hold on to, nothing to return to, only the peaceful drift through infinite space. Ahead, the final great structures of the cosmos await. As we drift deeper into the universe, individual phenomena begin to stand out against the vast background of space. These are not brief events, but processes that unfold over millions, sometimes billions of years. From this distance, they appear calm, almost motionless, yet each represents enormous forces shaping the structure of the cosmos. Ahead, a region of space appears subtly distorted. Light bends inward in graceful arcs. Stars behind the object stretch into faint crescents and curves. The darkness seems deeper than the surrounding void, as though space itself curves downward into an invisible well. At the center lies a black hole, not visible as an object, but revealed through its influence on everything around it. The black hole itself emits no light. Its event horizon marks a boundary beyond which nothing, not even light, can escape. But surrounding this darkness, matter spirals inward, forming a glowing disk of gas and dust. This accretion disk shines brilliantly as material accelerates, falling inward, heating to millions of degrees through friction and compression. As particles approach the event horizon, they move at significant fractions of light speed, their motion generating radiation across the electromagnetic spectrum. Radio waves, visible light, X-rays. The motion is smooth, continuous, and silent. From afar, the black hole is not violent, but orderly, a slow, inevitable gathering of matter shaped by gravity alone, patient and constant. The disk rotates with mathematical precision, each particle following the curved geometry of spacetime, spiraling inward along geodesic paths until it crosses the horizon and disappears forever. Some black holes are the remnants of massive stars, collapsed under their own weight after exhausting their fuel. When a star 20 times more massive than the Sun reaches the end of its life, no force can support it against gravity. The core collapses in less than a second, forming a black hole, while the outer layers explode outward as a supernova. Others are supermassive, residing at the centers of galaxies, containing millions or even billions of times the mass of the Sun. These giants influence the motion of entire star systems, anchoring galaxies in place as they drift through the cosmic web, shaping the evolution of their host galaxies over billions of years. Their formation remains partially mysterious. They may have grown from smaller black holes that merged and accumulated matter, or they may have formed directly in the early universe through processes not yet fully understood. Nearby, the faint glow of a supernova remnant spreads outward. Long ago, a massive star reached the end of its life, its core collapsing in an instant, releasing an explosion of unimaginable energy. For a few weeks, the dying star outshone its entire galaxy, briefly rivaling the light of billions of ordinary stars. The outer layers were cast into space, forming expanding clouds of gas enriched with heavy elements, oxygen, carbon, silicon, iron, forged in the star's core during its final moments. These clouds continue to drift outward, thinning as they expand, glowing faintly as they cool over thousands of years. The shockwave that once raced through the surrounding space at thousands of kilometers per second has long since softened, its energy dissipating into the interstellar medium, leaving behind a delicate, intricate structure, filaments, knots, and wisps suspended in the void. The remnant forms complex shapes, loops and arcs where the blast wave has encountered denser regions of surrounding gas, cavities where material has been swept clear, bright knots where magnetic fields have compressed the plasma. Each feature tells part of the story of the explosion, preserving information about the star's final moments. Within these remnants lie the seeds of future systems. The elements forged in the heart of the star, carbon for organic molecules, oxygen for water, iron for planetary cores, now mix with interstellar gas, becoming part of the raw material from which new stars and planets will form. Nothing here is wasted. Every ending contributes to a new beginning. The death of one star enables the birth of countless others. Further on, a neutron star rotates steadily, completing hundreds of rotations each second with extraordinary precision. This object, formed from the collapsed core of a massive star, is incredibly dense. A single teaspoon of its material would weigh billions of tons, compressed by gravity into a sphere just 20 kilometers across. The star's entire mass, greater than the sun's, packed into a volume smaller than a city. Yet from a distance, it appears small, unassuming, a compact sphere emitting narrow beams of radiation from its magnetic poles. These beams are powered by the star's rotation and its intense magnetic field, billions of times stronger than Earth's, which channels particles into focused streams. As it spins, these beams sweep through space with precise regularity, like a cosmic lighthouse. When aligned just right, they flash past our position with metronomic accuracy. These pulsars mark time with astonishing stability, their rotations more stable than the most precise atomic clocks built on Earth. Some have been rotating for millions of years without any measurable change in their period. Surrounding the neutron star is a faint halo of energized particles, glowing softly as they interact with magnetic fields. Electrons spiral along field lines, emitting synchrotron radiation that creates ghostly nebulae around some pulsars. The environment is extreme, yet stable, a balance of forces maintained over millions of years, a testament to the fundamental laws that govern matter at its densest. Elsewhere, vast molecular clouds stretch across space, cold dark regions spanning hundreds of light years. These cold, dense regions of gas and dust are the birthplaces of stars. From afar, they appear dark, blocking the light of stars behind them, creating the appearance of voids in the starry sky. Within, gravity slowly draws matter together, forming dense cores that will one day ignite and shine. Star formation is not sudden. It unfolds gradually, over immense spans of time. Gas cools to just a few degrees above absolute zero. Pressure builds as gravity compresses the cloud. Rotation begins as the cloud collapses, conserving angular momentum. Disks form around newborn protostars, flattening into planes where planets may eventually coalesce from dust and ice. These processes repeat endlessly throughout the universe, quietly shaping future systems. Each molecular cloud may birth hundreds or thousands of stars over millions of years. Some will be massive and short-lived. Others will be small and dim, burning slowly for trillions of years. Around them, planets will form, rocky worlds, gas giants, ice worlds, each following the same basic processes of accretion and differentiation. In some regions, clusters of massive stars flood their surroundings with radiation. Their intense ultraviolet light sculpts nearby gas clouds, carving cavities and pillars, pushing matter outward even as gravity pulls it inward elsewhere. The pillars of creation, the Eagle Nebula. These structures demonstrate the interplay between creation and destruction, where stellar winds and radiation pressure battle against gravity's inexorable pull. Creation and destruction coexist, interwoven into a continuous cycle. The radiation from young stars heats and disperses some of the cloud that formed them, preventing further star formation in those regions. But the compression from their stellar winds can trigger collapse elsewhere, seeding new generations. The cycle perpetuates itself across the galaxy. Cosmic radiation passes constantly through these regions, high-energy particles traveling at nearly the speed of light, originating from supernovae, black holes, and distant galaxies. Protons accelerated to enormous energies, atomic nuclei stripped of electrons, moving at 99% of light speed or faster. They traverse the universe largely uninterrupted, carrying energy across vast distances before occasionally interacting with matter, creating cascades of secondary particles. These cosmic rays have traveled for thousands or millions of years across the galaxy, bearing witness to the universe's high-energy processes, linking distant events across space and time. The universe here feels balanced. Immense forces operate continuously, yet nothing feels hurried. Events that seem dramatic from a human perspective unfold slowly on cosmic timescales. Explosions expand gently over millennia. Collapses take millions of years. Motion is measured, deliberate, and persistent. As we drift among these phenomena, patterns begin to emerge. Gravity gathers matter into stars, planets, galaxies. Energy disperses it through explosions, winds, radiation. Structure forms, dissolves, and reforms. The same processes repeat at every scale, from small stellar systems to the largest structures in the universe. We observe without interruption, without urgency. Black holes continue their quiet accumulation, patient and inevitable. Supernova remnants continue their expansion, enriching the cosmos. Stars continue their steady fusion, converting hydrogen to helium, releasing energy and light. Clouds continue their slow collapse, nurturing new generations. Everything moves forward, guided by physical laws that operate uniformly across space and time. The universe does not rush toward an outcome. It simply unfolds, moment by moment, epoch by epoch, following the mathematical principles that govern all matter and energy. Your mind has grown very quiet now. Thoughts arise and dissolve like distant stars appearing and fading. There is no need to hold on to anything. No need to remember. Only the gentle drift through cosmic processes that continue whether observed or not. Ahead, the density of structure begins to thin once more. Individual phenomena become rarer. The background grows smoother, darker, more uniform. The universe is preparing to reveal its final visible boundary. We drift onward, deeper into the expanding cosmos, toward the edge of all that can be seen. The universe grows quieter. Structures that once filled the darkness now thin into scattered points of light, increasingly rare, increasingly distant. Galaxies become smaller, fainter, reduced to the faintest glimmers against the vast background of space. Their shapes blur into indistinct patches of light, their colors soften and shift, and their presence feels increasingly subtle against the expanding void. We are approaching the limits of visibility. This boundary is not a wall or an edge in space, but a horizon defined by time and distance. Light from beyond this point has not yet had time to reach us. The universe continues beyond, infinite perhaps, but it remains unseen, hidden by the finite speed of light and the finite age of the cosmos itself. The observable universe is a sphere, centered on the observer, extending in all directions to the distance light could have traveled since the universe began. From Earth, this sphere is 93 billion light-years across, expanded by the stretching of space itself during light's journey. But we cannot see beyond this horizon. The light from more distant regions has not yet arrived, and may never arrive if the expansion continues to accelerate. Ahead, the distribution of matter becomes nearly uniform. In every direction, faint points of light are spread evenly across the darkness. These are the most distant galaxies we can observe, their light stretched and weakened by billions of years of travel through expanding space. These galaxies appear as they were in the early universe, when they were young, when star formation was vigorous, when the cosmos was denser and hotter. We are looking back through more than 13 billion years of cosmic history, observing an era when the first galaxies were assembling from primordial gas, when the universe was still clearing from its early opaque state. Colors shift dramatically toward deep reds and soft ambers. The expansion of the universe has elongated their wavelengths, carrying them slowly across the electromagnetic spectrum. Blue light emitted billions of years ago arrives as red or infrared. The most distant galaxies emit their light in ultraviolet wavelengths, but we receive it in the infrared, stretched by more than a factor of 10 by the expansion of space. Details fade. Individual stars can no longer be resolved, even the brightest. Spiral arms blur into formless glows. Entire galaxies reduce to subtle patches of light, barely distinguishable from the background, visible only through careful observation and long exposures. Between these distant points lies immense emptiness. Space here feels vast beyond comprehension. The separation between objects is so great that motion becomes almost meaningless. Distances are measured in billions of light years. Everything dwells suspended, drifting slowly as the universe expands around it, carried not through space but with space itself. The cosmic web dissolves at these distances. Filaments and clusters smooth into a gentle, nearly featureless field. The universe reveals itself not as a collection of individual structures, but as a continuous expanse, uniform, ancient, and calm when viewed at the largest scales. This is the observable universe at its furthest reach. A sphere of space centered on the present moment, on our position, extending outward in all directions, bounded only by what light has had time to show us. Roughly 46 billion light-years, in every direction from our current position, expanded from the original distance by the stretching of space during the light's journey. Beyond this horizon, the universe may continue endlessly, repeating similar patterns or forming entirely different ones. It may be infinite, extending forever with no edge or boundary. Or it may curve back on itself, finite but unbounded like the surface of a sphere. We cannot know. Observation comes to rest here, limited by the speed of light and the age of the universe. Faint radiation fills the void, the cosmic microwave background. This is the afterglow of the universe's earliest observable moments, stretched and cooled over 13.8 billion years of expansion. Originally emitted as visible and ultraviolet light when the universe was just 380,000 years old, it has been redshifted more than 1,000-fold, now arriving as microwave radiation with a temperature of just 2.7 degrees above absolute zero. This radiation is nearly uniform, almost perfectly smooth, bathing all of space in a subtle, invisible presence. Tiny fluctuations in its temperature, variations of 1 part in 100,000, mark the seeds of all cosmic structure. Regions slightly denser than average would eventually collapse into galaxies, clusters, and the cosmic web we observe today. The cosmic background surrounds us from all directions, a sphere of light from the universe's infancy, the most distant thing we can observe. It represents a wall of sorts, not a physical barrier, but an epoch beyond which we cannot see. Before this moment, the universe was opaque, filled with hot plasma that scattered light. We can see no further back in time using light itself. There is no center here, no preferred direction. Every point in the universe observes its own horizon, its own edge of visibility. From any location, the cosmos appears much the same, expanding, cooling, and growing quieter with time. The universe has no center, no edge in space itself. Only horizons of observation, different for every observer, moving with them wherever they go. The sense of motion slows further, becoming imperceptible. Galaxies drift at speeds we cannot measure from this vantage point. Light continues its journey, stretched thinner with each passing moment as space expands. The universe does not end. It simply fades into distances too great to reach, times too early to see, realms beyond the horizon of observation. Here, time feels suspended. Billions of years pass without urgency, without sound, without witness. Stars continue to age far behind us in the observable universe. New systems form unseen. Expansion continues without pause, space stretching smoothly, carrying distant galaxies away from each other at ever-increasing speeds. In the furthest regions, galaxies recede from us faster than light itself. Not moving through space faster than light, which is impossible, but carried by the expansion of space itself, which has no speed limit. These galaxies are moving beyond our cosmic horizon, crossing from the observable universe into the unobservable, lost to our view forever. The observable universe holds everything that can be known from this vantage point, from this moment in time. Hundreds of billions of galaxies, each containing hundreds of billions of stars, each star potentially hosting planets. Nebulae, black holes, neutron stars, clouds of gas and dust. All of it suspended in a sphere defined not by physical boundaries, but by the limits of observation itself. Beyond it lies possibility, mystery, and continuity. What exists there does not need to be seen to exist. It remains part of the same unfolding cosmos, following the same physical laws, containing perhaps infinite galaxies, infinite stars, infinite worlds. The universe beyond our horizon may be unimaginably vast, or it may curve back on itself. We simply cannot know. The darkness here is not empty. It is full of potential, full of history, full of quiet persistence. Every particle, every wave of light, Every subtle fluctuation contributes to the vast, ongoing story of the universe. Every quantum field, every dimension of space, every moment of time participates in the cosmic evolution. The universe began in an extremely hot, dense state, the Big Bang, 13.8 billion years ago. From that initial moment, space has been expanding, matter has been cooling, structure has been forming. Particles formed first, then atoms, then stars, then galaxies. Chemistry emerged. Complexity arose. And on at least one world, perhaps many, life awakened to observe the cosmos. As we drift at this final horizon, there is nothing left to approach. No destination remains beyond this point. The journey does not stop. It simply settles into stillness, into acceptance, into the peaceful recognition that some things lie beyond reach, beyond knowledge, beyond observation. The universe continues to expand. Space continues to stretch. Light continues to travel, though the sources grow dimmer and more distant. Dark energy drives the expansion, accelerating it over time, ensuring that distant galaxies will eventually recede beyond all possibility of contact or observation. And in this immense, quiet expanse, there is room for rest, for reflection, for calm. The journey outward has revealed the structure of the cosmos at every scale. From familiar planets to alien stars, from nebulae to galaxies, from the cosmic web to the edge of observation itself. Your breathing is now barely perceptible. So slow, so gentle. Your body has released completely. Your mind has expanded into the vastness, thoughts dissolving like distant galaxies into the cosmic background. There is nothing more to see, nothing more to reach. Only the quiet darkness, the faint glow of ancient light, and the peaceful knowledge that the universe continues, expanding gently, whether observed or not. Rest here. Let the distant glow soften further. Let the darkness deepen around you. The cosmos will continue its slow unfolding, its patient expansion, its quiet evolution long after observation fades, long after awareness dissolves into sleep. The stars drift. Space expands. Time flows. And you drift with it, peaceful and still, suspended in the infinite now, in the gentle darkness between moments, in the quiet space between breaths. Rest. The universe holds you. The darkness embraces you. The silence carries you. Drift. Sleep. Peace.